A telescope labeled f/5 has a focal length 5 times its aperture diameter. That ratio is called the focal ratio, defined as n equals f over d, or focal length divided by aperture diameter. In labels such as f/5 or f/6.5, the number after the slash is the value of n, and when spoken, they are simply read as f5 or f6.5. So the slash here is usually omitted in speech. As we already know, the converging beam formed by the objective lens or primary mirror makes a cone of light. A smaller focal ratio means the rays converge at a larger angle to the optical axis, forming a less pointy cone, while a larger focal ratio means they converge at a smaller angle, forming a more pointy cone. That geometry determines how large the same patch of sky is formed at the focal plane. A smaller focal ratio forms a smaller image of that patch and concentrates its light into a smaller area on the sensor. A larger focal ratio forms a larger image of the same patch and spreads that light over a larger area of the sensor. In imaging, a fast telescope has a smaller focal ratio and reaches the same image brightness in less exposure time, while a slow telescope has a larger focal ratio and requires more exposure time.